Welcome, everybody. It's been a very exciting CES so far. It's very nice to see everybody here. Can't walk anywhere in CES without seeing AI everywhere. Plastered over every poster. It's absolutely omnipresent here. The real question, of course, though, is how do you get value out of AI? How do we actually put it to work? And so part of what we're going to talk about today is how do we get the unlock? How do we scale AI to achieve breakthrough transformations? And we thought we'd do that, exemplifying it with our friends from Goodyear on with us. So, with that, and we're going to do that in a way that not just talks about, we're going to talk about it in two ways. We're going to talk about how AI actually changes the work itself, so from product development to engineering, to how AI can actually impact the product itself. So, with that, let's talk a little bit. I'm going to give a little bit of context and a setup before we start talking with our friends here. So, unlocking that breakthrough transformation. Where is the return? Many of you are very familiar with the famous MIT report that's out there in the market. Lots of rhetoric around this. Tens of billions of dollars that are out there being invested. And the key question, of course, is where is the ROI? All these scenarios and use cases, where is the value being unlocked? We think about this very simply. We think about, there is an equal part of this around what the ideas are, the innovative and tangible outcomes to come with, but really the unlock, a key part of it, is the scalable technology, the foundational technology that also needs to be there to be able to take advantage of the AI. There are no shortage of the ideas of what can be enabled with all of this AI, but the technology foundation has got to be there as well. So when we talk about the technology, certainly AI is at the core of it, what it's been able to do. The agentic disruption fundamentally has reinvented what software even is, moving from deterministic lines of code when we think about software, millions of lines of code, rule-based, deterministic, now moving to intention-based, goal-oriented capabilities that can create the same outcomes in a much greater speed. But AI isn't the only technology that's out there that's evolving and advancing. There is a lot of other technologies. The advances in hardware and compute and cloud, what is going on with sensor technology, wireless technology. And the real point on all of this is the real unlock and the new opportunities are coming together as all of these are converging and being assembled to create new capabilities. And while there are all those other advances, certainly AI is at the core of the biggest disruption that's here, and agentic. And to keep this in a very simplistic view, if you just think about four kind of key terms that are out there everywhere, we think about on the left, the foundation models, the LLMs. This is really the breakthrough technologies in agentic and in AI. What they've been able to do in the LLMs, from generative capabilities to what's now been coming out in reasoning, has just been nothing more than amazing. However, it's really the second bucket that we want to talk about and we're going to bring to life a bit with our friends here at Goodyear, which is also the institutional knowledge of your own organizations, of your products. The LLMs, as trained as they are on publicly available information, what we really want in order to make agentic actually come to life is we need to fuel those LLMs with the information from your institution, from your organization, with your product information. That's the fuel that these LLMs need in order to really create new outcomes. So the knowledge side of it and creating the architecture that ingests that and gives access to what you see on the right, the agents, which can now go to more than just answering questions, but actually doing some of the work, to agentic systems that start to tie all these together. They have to be fueled with the institutional knowledge of the organization. So, and that brings us right back to our friends here at Goodyear to try and make this a little bit real. I've had the privilege of going over to the Goodyear booth, and I would encourage everybody here to do so if they haven't already, because you can really see how this comes to life and is very tangible in the products, and also explaining how it unlocks completely new opportunities and how Goodyear is putting all of the knowledge and information and data that they have to use to really unlock new capabilities. So let's get into that a little bit. But first, I wanted to ask Chris and Werner if you could just say a little bit about yourself and your role at Goodyear.
Sure. So first, Chris Helsel. It's a kind of a long title. All that means is I report to the CEO. And I've been our CTO for 9 years. I've been at Goodyear 30 years. Originally hired as only the third person doing computer modeling simulation. And maybe just real quickly, the job was go get rid of testing. So you could fail miserably at your first job and still be CTO because we did that. But what that's given us is really an ability to use both of those capabilities, and with that, all the data that now comes with it, which is how we're building out really two pieces of our strategy. Number one, and you mentioned it, David, is how we do our work. That's more the internal facing. And we'll get into a few of those examples, I think. And then secondly is the external facing, or our new products. And in particular, Werner leads that area. So maybe with that, Werner.
Yeah, thank you, Chris. My name is Werner Happenhofer. I joined Goodyear about 3 years ago, and I lead our tire intelligence activities, which is really quite complex because it is all about optimizing tire intelligence, how we use it for our fleet management business, where we have been really successful in the last 15 plus years, and then also use basically the same technology, and that is software, that is hardware, sensors, and turn that into business by implementing that solutions into ADAS. ADAS, cars today, 2, and you are better in counting all the pluses behind the 2, but then also 3, 4, all the way up to AVs. And that's been a really exciting journey so far.
Awesome. Well, so why don't we start some of the questioning with turning it over to you, Chris, to talk about tire design and development, and to your earlier point of how the work is actually done.
Right.
How at Goodyear has AI actually impacted and changed some of the work in design and development?
Yeah, maybe I'll go with two traditional machine learning type approaches. And in both of them, we reference as expert recommenders. So the first one is actually in the design. I know a lot of times you walk past your tires, but believe it or not, they have about 65 performances that we use to certify a tire. 1,000 nearly variables that you could tune, whether those be those external features you see in the tread, the shape of the tire, but more importantly, those constructions and even the materials. And in those cases, what we're trying to do and what we've built is off of the thousands of specs with all of that test data, all that model data, is you can say, here is my performance targets for these 65 different parameters, and it'll give you guidance on, hey, why don't you try this design? Becomes really important because we get asked oftentimes now by our most discerning OEMs, hey, before we even are going to go with an RFQ, can you please, tell us, can you come up with a feasible tire, that'll actually meet these performances? Now, what we've done since is those points that it would predict, we link it into our simulation. What we haven't done yet to automate those workflows, and that's where we see an opportunity for something like Agentic, right? The second one is really in materials. At our core, we're a material company. And when you think of each of the materials that are in your tire, there's actually 30 components. Each one could have up to 60 ingredients. And what we've put together there is actually something that solves the inverse problem. So what we look for is, here's the characteristics that we seek, go give me the ingredients, right? And what kind of a speed up have we seen in the first one? Something that might have taken like 8 weeks now is about a week and a half to run that same analysis to come up with that recommendation. And on the materials side, it's about a 10-month process that's now about 2 months. So significant speed ups, but again, those are pretty traditional machine learning based on that data that we have.
But still, a big key that you're referencing in here is the amount of data that you've been able to go and leverage. And we're gonna get into it a little bit more about how you're putting some of that data to even more use with AI. But just taking what you just shared a little bit and thinking about the global operations that you have, how are you able to scale some of these solutions, the innovations that you've been creating and the how to do the work? How do you get that to scale to your global engineering teams?
Yeah, so interestingly, maybe, and that fits really well with an initiative that we've had going. About a year ago, we've kind of went from more or less 3 regional businesses to 1 global. And with that, more of these global central functions really have to drive. So one of the things you get enabled with these systems is actually getting folks to work together who maybe hadn't before. Maybe they've been siloed, geographically. That's been a positive, and it starts generating some pull. But number one is obviously the trust. And the trust really comes, I think, from number one, are we all just approaching this as a productivity optimization? Because that's code for your people that says you're getting rid of me, right? And the first thing people go to is, what is this going to mean to me? And so what we've done, I think, tried to do, it's not always the easiest, is you've got to have a good purpose. What is your purpose? We'd say as a company, it's be number 1 in tires. For our organization, which is global product design and development, we have to have products that deliver you most safely, most efficiently, most sustainably. And so if we could connect these into how is it enabling our people to do that better, I think that helps build that trust. We did build, one other example is we get them very much part of saying these tools are good or they're not good, okay? And so for that, we have a company been in business a long time. We have 1.5 million technical documents. Nobody likes sitting around reading 1.5 million technical documents when they want to start a new project. So what we did was we actually took an enterprise version of ChatGPT, and we built something that allows you to efficiently go through those documents and come back with insights that then allow our engineers to plan their next project. So with that, though, they had the subject matter experts have done all the validation, ensuring no hallucinations, that the citations are correct. That really built a lot of credibility because those are the respective technical leaders in our organization.
That's great. So a couple of different themes that just came out of there. So one is the ability to process all this vast information that you have with your chat TO, as you were talking about this capability that you just described, and being able to use OpenAI and apply it to all of your information to be able to search through it. But the other thing I think that's really great that you just brought up is the trust component of it as well. And so, which we see with all of the organizations that we work with, that still being a major change management adoption, both in terms of the accuracy of the information that has to come out, but also the intention that you just described. Yeah. So Goodyear's doing a lot of good work in changing the way that you actually do the work, how you do development and design. Maybe we talk about the product itself and some of the innovations, which were very exciting, and being able to even put my hand on some of these new sensors and things in your booth. Maybe we talk a little bit about tire intelligence and the product itself. Werner, it'd be great if you could maybe even describe to the group a bit about what tire intelligence is.
Yeah, absolutely. Thank you very much. So our tire intelligence, we call this Sightline, is actually a suite of software algorithms and sensors. Predominantly, we have a tire-mounted TPMS sensor. Most of you might know the TPMS sensor. That's the sensor that starts really bugging you when temperatures get cold. Of course, on your dashboard, there is this light, and you say, what is that supposed to mean? Just tells you that the inflation is a little low, the pressure is a little low. A tire-mounted TPMS sensor has that functionality, but more. And so we actually generate a lot or collect a lot of data from the tires, and also how the tire interacts with the road. So we use that information, and we always have, even in the early days when we did not have that type of sensors yet, and used the TPMS sensor, we always used that information and the insights. We collected that data, we used telematic control units. We stream that data to a cloud, we create wonderful dashboards and provide that information to fleet managers. And they love us for that, because we tell them, hey, on that truck, the right steering tire is a little low, and you want to probably pump that up, talk to your driver. Of course, that will ultimately save you some fuel. Or the tire's running a little bit hot for whatever reason. That certainly will cause additional wear on your tires, and you should be aware about that. That were the beginnings. and ever since 10 years about, we have really embarked on enhancing these insights by the means of using software. So we basically developed software, predominantly rule-based systems. That means physical-based models. So we use that. We know what's going on with the pressure. We know what's going on with the temperature. And we actually can also do some calculation based on tire models, which we have. Of course, we know a lot about tires. What the tire wear might be. That was not good enough, so we added a lot more information coming from the vehicle. We collect that data as well. We stream this data in the cloud. And then we said, hey, wait a minute. To do this in a good way, we need data science. We need people that understand how to work with that data. So we started to fusion the data, curate the data, and could create even more insights. That's fascinating. And now, David, we're at the point where we say we can use AI. So we're transitioning for some of these insights in using machine learning models, machine learning code. One of these features we use in the fleet management area is our dynamic core, and that dynamic core can calculate, based on all these data which we collect, what the tire wear is and what the tread depth is of each of these tires on a truck. And that's remarkable. So we use AI, and it's very innovative to generate even more insights. And that is certainly very good information for fleet managers because it helps us to manage the tires even better. And then when you think that we also adjusted based on these new insights and based on the ability of AI, that we changed our business models and offer tire as a service. So we are not selling the tire, we're selling the service. We are managing our own assets, and we have the interest to do this in the best possible way. And this is where we use all this data and work with those data.
So there was a lot that you just unveiled there. So if I unpack this a little bit, first from a technology perspective, the ability of the technology that you have in there. Again, the advancements in the sensors that are now there, the wireless technologies from the RF to just the new wireless bands, to be able to get all of this data streaming out of, and by the way, you can really see the sensor. They've cut it out of a tire conveniently at their booth, to actually see how small the sensor is, and what it's doing in the tread, to be able to then have that information, telemetry out. There's so much potential. We're going to talk a little bit about the potential. I took a taxi ride just back from the convention center. I won't say what car, and won't say what tires were on it, but what was very clear is the TPMS was telling me the back right tire only had 29 pounds. The driver had no issue with this, while the others all had 45. You have, even in your booth, the ability, one of the examples they have is the auto-inflate capability, right? So this is not a matter of going forward of just the ability to say, hey, look, we've had this information, as you said, for years around TPMS, but imagine the ability to a fleet to be able to keep the tires inflated at the right pressure and actually action some of this. Yeah. These are the kinds of innovations that I know you talk about in your booth, and you're moving really from all the data that you've been collecting for years through machine learning. Where else do you see some of this going in terms of tire intelligence on, taking all of that data and now thinking about the inference and actually doing AI on the edge?
Yeah, absolutely. So that's the second big part we actually do with tire intelligence. We use tire intelligence and really implement tire intelligence in the vehicle motion controller now. So basically we are providing the software-defined tires to the vehicle controller. Control engineers love that input because it enables basically to adjust all different type of ADAS systems, the braking system, which means with that insights, the systems can be configured in real time differently, not just use data, predefined data, because we can really make use of those data now. Based on this, we help that these systems work at their peak performance. that helps, for example, to reduce the braking distance. And if you think that a worn tire usually has a little longer brake distance than a new tire, so we can actually gain some of these losses back with our technology. And that technology is embeddable. It's available, it's embedded. What we are doing now is, of course, the physics-based models, they can do only that much. We're now really working in also bringing AI models, machine learning models into the edge, actually in the sensor, and really execute these machine learning code in the sensor, so that helps us to generate even more information, especially when we talk about tire wear. And we pair this with our tire knowledge. That's in the sensor. These models, and people that are very much aware about AI and machine learning know, these models are pre-trained with the data we have from our tire insights, from our tire tests.
And maybe I bring it back to Chris a little bit, and I know we just touched on this a little bit, but there's no periodical, and as a car guy here, there's no periodical I don't read that talks about all the new safety desires that are out there, what's going to happen with automatic braking systems, and just how much more rich and meaningful they can be with this kind of technology. How are you working with the different OEMs right now around improving safety? How does this technology actually manifest itself to fleets and car manufacturers?
Yeah, at the core, the insight for us when we even started down this intelligence area was, and it sounds simple, we're the only thing that touches the road. And, when you go driving and you're going to go hop in your Uber or whatever it is, you basically have 4 palm-sized patches of rubber that transfers all loads and forces from that several thousand-pound vehicle to Earth. That's it. That's what's keeping you stuck, okay? And we have done that for more than 125 years, 128 years now through physics, chemistry, mechanics. And what we said was, when we saw all the trends coming with IoT, et cetera, is, well, why don't we just add another leg of an engineering discipline, which was digital, right? And so that's what's really was the insight in about 2017 that kind of had us build this all out. And now when you start thinking about it, what can we do? Well, when you have a worn tire and a new tire in its most simplest, and we built collaboratively a controller with TNO at the time 2 years ago. We might have had that in our booth. And what we did was to actually show that, you lose significant stopping distance if that tire is worn versus new. Now, though, by knowing exactly what is that tread depth, what's your state of inflation, what's the temperature outside, is it wet underneath the tire, isn't it? We can present information that now gives an individual signature of that particular tire that can be passed directly into that braking controller. So thinking of a smart ABS versus maybe preconditioned with a generalized tire model, you know exactly what's happening here. And we recover up to about half that stopping distance, which is significant. I mean, you might be talking 3-4 meters. 3-4 meters is enough to prevent you from hitting the back of somebody else. So when we think of the new NHTSA requirements coming for AEB, we think there's potential opportunity. We really see a lot of opportunity as well through these multiple levels of ADAS and ultimately in autonomous, because you do a great job actually being part of this whole system. Whether it's your butt in the chair, your hands are on the wheel, you're feeling through your feet. You can come up with some defined path that you want to take and speed, etc. But you need a feedback loop on, can I really execute this, right? And what's really happening underneath the vehicle? Because it might say I could drive at 50 miles an hour, and you can on a dry road, but if you're on ice, no, you can't. And so that's really, I think, the purpose and thing that we bring, right? And that simple example of what we did with a braking system and built that whole out into a controller and a proof of concept vehicle, et cetera, I think is just one illustration of the job you can do with this information.
That's perfect. And I think, so if you add it all together, I mean, number one, some great examples of just how you're doing work differently at Goodyear by starting to embrace, you've always been embracing data, you have very unique data, you've been embracing that to start changing the way that you actually do work, and now adding AI on top to drive more efficiency, to actually looking at not just embedding new sensors and the new technologies to create new products, but even entirely new business models around fleet service management. And all of that coming from the knowledge that a foundational technology needs to be there, and how do you capitalize, leverage all of that unique data that you have. I think they're great examples, and you can actually touch and feel them and see them, which is fantastic. So we have a couple of minutes, so thank you for sharing those stories. We have a couple of minutes. We'd invite, if the group gathered here has any questions around it, we'd love to be able to talk about some of them. I know the bar has already been opened, but we also would welcome any questions related to it. We have a mic runner out here. I see a few people.
Yeah, I think my question is, some of these breakthrough technologies obviously come at the cost of, OCM, change management adoption. What are the biggest hurdles that you faced in implementing some of these solutions, and more so from an angle of adoption from the final person standpoint, or maintenance, or whatever operators who work with this?
Sure. I would say the number one thing that you find is what you would think with any other, is the cost. And so what we've been trying to drive is that the cost of that in particular sensor, because we have sensorless solutions where we can just pull the information off the vehicle. You just only can get so far. Our goal is to get it exactly to the price of the existing TPMS. And now with this in there, it's basically the TPMS plus the accelerometer that gets you those additional features. Then with that there at that same cost, now you can start adding these things and then bring the value. So the number one thing is there's not a lot of tolerance for adding cost right up front. There just isn't.
In how you engineer and manufacture tires today, it's very easy to say, hey, it's a great use case and I'm going to implement the use case, and you get marginal value. What's your perspective on, because there's a lot of effort intensive activity in the whole engineering value chain. So what's your perspective on ensuring that you're driving value wherever it's available versus, let's say, the small piece that's really, really cool?
Yeah. I think maybe the concept I did not hit on was, and you could say it, but your people watch. Are you really doing it? Are we really doing this to augment and make their job better? And so that augmentation concept is really key in getting that trust that that's really our objective. And I would say, again, back to currently, if I'm a tire designer inside of Goodyear, because of just so much legacy debt on our IT systems and things, you might have to know 30 softwares. So one of our number one projects as we think about the agents, Accenture, is how do we make it so that an engineer in just a natural language can interact with these without having to be an expert in running all these softwares? We then make their job truly better, the what's in it for me, right? So beyond those kind of things, one of the things is at the final release of any tire, we've got about 25 people who will all get together, long in the tooth engineers, new engineers, and those who ran the data, those who did the modeling, and we have what's the final DFMEA. Did we really meet these requirements? And it's never as simple as you meet them all, right? Because that would be too easy. It's a nuanced final decision of, is this product ready to go to market or not, okay? That's an area where we see where agents could really come and help do that. There's a lot of formatting and bringing the data together and those things. So again, we see a lot of low-hanging fruit in those kind of activities that your engineers just don't want to do. So I would search for a lot of those. And again, that's part of that build trust. My job is better. I get to do more creative work than what I've been doing. But it's still change management. Some folks might enjoy that work, right? So you're still going to make your way through that. But I think that augmentation concept is one you really got to get proof of concept that you're really following that, and confidence in your folks.
They give you the mic that doesn't work.
Yeah, I'm loud enough usually anyway, but it did work.
There you go.
First, love the tires, have them on my Tesla, so thank you very much.
Thank
on
you.
The palm size of 4. Never thought of it that way, but you're so right. I loved your comments around engineers, but as we look at agentic, you start to think across functions. And have you gotten into that in some of the change management and some of the things where your engineers can come up with something, but how about the rest of the organization? And how are you addressing some of the change management that goes with that?
Yeah, you know, I'll be very transparent on this. We've been sweeping a lot in front of our own doorstep. And so, you know, before I'm shaking my finger at my other peers on the SLT that you should be using this, I better be, you know, get some wins on our own. But truly there is, in particular, I'll say between like our strategy function, our product development function, and then our manufacturing. And really there is where we're starting to see. So in our quality, and we've got a lot of data that flows, you know, think of your CPKs and things on, you know, your material extrusion. We make our own parts and we assemble them, then we basically bake them. As you think of that data, how do you take that along with how is that connected into my engineering requirements, right? So there we do have some connectivity and that cross-functional work. And that is moving, and I would say part of the reason that moves is because we have leadership alignment that's driving a common expectation. And we've made a project that truly from the get-go was a cross-functional project, okay? But yeah, breaking down silos is always something. We've been a little fortunate, I should have said in my intro, actually for 3 years, up until this time last year, I was also in charge of all of our worldwide operations. So I had manufacturing, supply chain, et cetera, on top of the CTO role. By the way, I traded that for running the race business, so that was a great trade, by the way. Nothing against you who do operations, but racing's a little more fun. But the bottom line is that team had been driven to work together. So there is some work there, definitely. But, you know, there's so many, talk to all of you. The decisions you make in product development, boy, you can make your life miserable for your manufacturing folks, right? And I had to eat my own dog food, and so, you know, I definitely am sensitive to that.
Awesome.
Maybe a question. So thank you for the presentation. It's quite impressive. I have a question about predictive analytics, and it's a debate I have often with technology players and industrial players is, with your technology, you're capable to estimate the wear tire at, let's say, a day accuracy or maybe a week accuracy. Do you see like the business value of doing that versus estimating the tire health at, let's say, a month accuracy? Is it worth it? You know, and we have often this question, you deploy a lot of analytics to have a detailed vision, but isn't it enough to have like, okay, the precision and the accuracy of the tire of the month? Yeah.
Maybe I'll start and then I'll let you go. You know, you think of tread wear, it's a slow phenomenon. You know, you're talking about fleets, front tire on a steer on a 18-wheeler, 120,000 miles. So how much does it change, right? It's more important probably in leak detection in that particular case, where what we find is our algorithms could actually start triggering, saying, look, you're starting to see some change in your inflation, and they'll even recommend, you know, hey, why don't 2 stops from here, you can go get service and get it checked out. So I think that's the use case dependent. I agree with you, adding fidelity on a week versus a month, but for something like a slow leak that could be indicative of an injury to the tire, it's much more valuable. And I know you've got a lot of experience.
Yeah, no, absolutely. I mean, the topic of predictive maintenance, you don't need a day or a week, not for tread wear. That's really not necessary. What's always interesting is generating insights if, you know, a tire is operated not at its optimum. Let's say it's operated deflated or not properly inflated. Or for whatever reason, you get a hot tire, which happens if it's not really fully inflated, but there might be other aspects. You could have some issues with your brakes and the tire is hot. That usually generates extensive wear, and to know that and to have that information helps to provide additional information in terms of a warning, predictive, you know, to say, well, wait a minute, check out your tires. And again, as I said earlier, with the ability to really manage this huge amount of data and managing our own assets, we are liable for that asset. It's our asset, so we got to make sure that the tire is operated properly. And for this, you mentioned it, David, we have additional inflators which we use as well. And so we get a lot of information. We get the information how the tire reacts when we inflate them with that system. This is what Chris was alluding to, that we can actually really distinguish between different categories of leak rates. So we know, oh, there is a leak. We give a warning. We know the tire is good for another 2 months. But we already see there is something. So we better check it out. And this is where we get into a fidelity where we can really offer predictive maintenance or information that is really at the scale of it's maybe only 5 hours, so you got to do something now, or it's 3 months, or it's a week. That helps. And we use the same technology, obviously, also when we implement this in passenger vehicles, in ADAS systems. Here, usually, the OEMs are very interested in what we call the rapid air loss. Of course, we all know a tire never bursts. There's a rapid air loss. And detecting rapid air loss really within 300 milliseconds and provide that information to an stability controller, vehicle controller, or an adaptive suspension system that really can save life. I mean, you really can control the vehicle. You know that tire is blown up, it's useless, but you can manage, stabilize the vehicle, keep it on track, slow it down. That is quite cool stuff. And this is information where we really look into these different levels of how much time do we still have.
That's perfect. So first, I'd like to very much thank our friends at Goodyear here for sharing. I really think the story here really exemplifies what you can unlock, new capabilities, new business models, just new product capabilities as a result of some of these advances in technology. Thanks again. Thank you, everybody. And please stay for the reception and the bar as well. You're invited for that as well. Thank you very much, everybody.
Thank you.
Thank you.